Hey all, I'm Sandeep Atluri. I'm a senior manager in Alexa AI. Here's my colleague.
Hi, Devesh. I'm a principal product manager in Alexa AI, along with Sandeep.
Hey, here together we are here to speak about natural and conversational shopping experiences. So we've got great content. Let's dive deep into it. Online shopping has taken over in the last few years because it provides significant benefits to the customers, where customers have lots of choices at their own convenience. Now let's take a typical shopper journey and break it down how they shop. We've bucketed them into 4 broad categories, with the first one being really the interest. This is where it all begins. There is a need that comes from the customer that motivates them to buy a new product. When they find that need, they go on this search phase where they go and figure out which products they want to buy. And once they figure out a subset of products, they research amongst all the available options to figure out a better one that fits their use case. And eventually, this leads to a purchase happening. Now, this journey that we just talked about is fairly nonlinear. Customers move back and forth between these journeys. Based on the user research and customer studies, we found that customers spend quite a bit of time in the search and the research phases. And let's look at these 2 phases in how customers actually spend their time. Customers, when finding their products that fit their use case, most likely opt to do research, especially for high consideration products or for categories they have no experience with. This research typically takes place in the form of reading online research, reading customer reviews, reading customer question answers, reading web expert recommendations, so on and so forth. Then they use this information to filter down products that actually fit their needs and do a sub-selection. This research typically takes days or weeks or even months, depending on the price point, depending on the familiarity of their product. While going through these kind of product information, there are quite a few pain points that customers usually face. Now let's take a look at what are these pain points that customers face. Online shopping is great because customers have access to a large selection of products at their fingertips. While this is amazing, it also provides customers a choice dilemma. Which products do they buy? They have so many options. They have to compare a large number of products for the aspects they care about. They also find it very difficult to navigate and filter products for the constraints or the specific needs that they have for different shopping experiences. The amount of information available on these products these days is overwhelming and puts significant cognitive load on customers to do their research. It is also difficult for customers to find really reliable product recommendations across the sources they trust and aggregate them to get a consolidated view where they can take an informed decision. Customers are also facing a lot of difficulties because they have to switch modalities often. They start using their laptops, phones, tablets, which requires constant context switching and restarting their shopping journeys. Here is where we think Alexa and a voice-forward experience can really simplify customers' experience. Now let's take a quick video around how we Alexa and shopping teams are solving this problem.
Alexa, show me gift ideas.
One moment, please. I looked around and here's what I found for gift ideas. Try saying, show me gifts for boys, or show me gifts for holidays.
Find me holiday gifts for families.
Showing some gift ideas. Amazon recommends Christmas gifts holiday premium basket hot cocoa, premium gift basket for family. To learn more about it, say show me number 1. You can also say, show more ideas.
Show more ideas. Alexa, show me number 6.
Showing you gift suggestions from popular mechanics.
Go back. Alexa, show me number 1.
Showing you Christmas gifts holiday premium basket hot cocoa, premium gift basket for family. It has average 4.5-star rating and costs $25.99. Try asking me any questions you have about this product.
How much does it weigh?
The package weight of the product is 2.02 kilograms. Did you have more questions?
Alexa, add to cart.
One moment. I added it to your Amazon cart for review. Let me know what else you'd like to see next.
Alexa, stop.
Bye.
Awesome. This is a really cool experience compared to how customers were shopping previously. There's a lot that was going on in this video, so let's try to unpack and look at some of the salient pieces in it. A delightful conversational shopping experience requires customers to have, one, high quality recommendations. They should have the ability to naturally talk to the agent or assistant to give their needs. They should have the ability to do thorough research. And lastly, they should have the ability to ask questions about the products themselves. Now let's dive into the shopping recommendations, which is really the heart of the experience. With the conversational shopping experiences with Alexa, it becomes your one-stop place to get quality recommendations, not only from Amazon, but from other trusted, reliable sources without having to visit these multiple sources. Customers can now use this experience with the convenience of voice and have access to high quality shopping recommendations. Customers can now find inspiration, find products, navigate different experiences, navigate different categories while finding products that fit their use case. Alexa can also guide customers with smart and timely hints to help customers narrow down their choices. With these updates, shopping experience is much more delightful on Alexa for customers now and for shopping their loved ones than for before. Natural conversations. How many times have we found ourselves reformulating our queries where traditional search engines or shopping engines don't understand our intent? Wouldn't it be nice if these engines would understand us like a shopping associate at a physical retail store do? In this example you see on my screen, Alexa, my mom likes gardening. Alexa actually understands it and reformulates it to gardening gifts for mom based on the previous context and the previous dialogue history. The customers didn't have to repeat themselves or frame it in such a way that machines understand. This feels natural, doesn't it? Customers also often find themselves doing thorough research, spending hours and hours when buying high consideration products like a camera or buying indoor furniture, or in this case, a planter. This turns out to be much harder because there's vast amounts of information on the web. Customers have to read, process, and synthesize information across various sources and then take an informed decision. This is really hard work. However, now with Alexa, this becomes much easier because Alexa does this work on your behalf by not only aggregating information across various trusted sources, but actually summarizing and making them into a bite-sized insights that help customers make these decisions much faster and help them make informed decisions. Lastly, customers have a lot of questions about the products they purchase. Today, finding this information again is hard because customers have to find this either on product detail pages or ask search engines about these products. With Alexa, this becomes now much easier where customers can actually ask questions about the product at any point in the journey, and more importantly, they can ask it in a very natural way. As you could see in the example on the slide, what size is this is a question that customers can ask instead of asking, hey, what size does this planter come in? This natural way of asking questions makes this experience much more delightful than what customers have been used to before. Now let's take a quick look at how this experience is built at a high level. On the screen, you could see a architectural block diagram. On the left side is the core pieces where the offline processing happens, where it begins with web crawling, where Alexa is gathering information from various sources, making it the most up-to-date smart assistant. Information, however, that Alexa gathers is often not in a user-friendly or a readable format that machine understands, which requires an additional processing step called information extraction. Once information is extracted in a structured format, we then send it to a neural document summarization module that summarizes and synthesizes this information into sizable chunks that are easy for customers to understand. This serves as an input into a multimodal neural retrieval engine that helps retrieve this information based on customers' contextual queries. Now, shopping recommendations, contextual question answering, bite-sized insights, all the previous customer-facing features you have seen are powered by this multimodal neural retrieval engine. At the heart of this is Alexa Conversations Dialog Manager that helps actually have a conversation with the Alexa. The key features that Alexa Conversation Dialog Manager enables this conversation to feel more natural is by leveraging the visual and spoken dialogue context, named entity recognition, contextual query rewriting, and API prediction and argument filling. We'll dive into each of these in the upcoming slides. Let's begin with information extraction. Let's first define what information extraction even is. Information extraction is often referred as the process of converting unstructured information into structured information that confines to a predefined schema. Web pages or documents are the most common and powerful source for humans to acquire knowledge. There are billions of websites that contain rich information about objects, topics, and entities. However, these websites don't adhere to any particular schema and are laid out in a very heterogeneous manner, making it extremely difficult for extracting this information. Moreover, this information is structured inside tables, images, lists, forms, videos, audio files, making it even more challenging problem. Despite these challenges, information extraction as a field has made tremendous progress in the recent years and has enabled many downstream applications like recommendations and question answering systems. Now let's look at ways to extract this information from web documents in a scalable way. Like any other machine learning or deep learning models, information extraction relies on supervised labels for machine learning models to train on. However, acquiring these labels is an expensive process and time-consuming process. To tackle the scarcity of these labels, we begin by taking a few sample websites, we call them seed websites, and where we annotate them manually for supervised label. As shown in the example in the slide, the web document is annotated with key attributes like product name, product link, aspects, review text, so on and so forth. These supervised labels are then passed into a transformer-based models to extract the structure. The transformer-based models incorporate the HTML layout into a representation of the web document along with the textual data that is present in the document. The models are architected in such a way that they capture rich attention patterns for embedding representation among all the input tokens, including the page layout information. These models are then fine-tuned using few-shot learning techniques so that they are not dependent on large batch of training samples and can adapt to the new domains or new websites where the models have not seen in the training phase but are actually available at the test or the inference phase. Now let's move on to how the shopping recommendations are generated. Shopping recommendations are really the heart of this experience. The goal here is to help customers navigate through a large number of products by providing them the most relevant and trustworthy recommendations based on the context from the customers. Shopping now on Alexa will not only surface recommendations from Amazon, but from other reliable sources that customers have been using in the past. Additionally, when purchasing in categories that are new or less familiar with, Alexa can now suggest smart hints where the customers can use them as guides to discover new products. These recommendations now can also be filtered to specific preferences like price or delivery date or subcategories using voice or using text, using touch on Alexa with screen devices. Now let's look at the secret sauce behind how these recommendations are actually generated. It all begins with a user question that comes into Alexa. This, combined with the conversational history from the previous dialogues, is sent into the query resolution or a query understanding module. In this module, the goal is to extract deeper semantics of the question by performing named entity recognition, by extracting product names, by extracting brands, and having a really deep understanding of what the customer query is. Independently, at an offline stage, the web documents and Amazon products are indexed into a multimodal neural retrieval engine, which is also has an input from the user questions and the resolved queries. These query and documents are now represented into an embedding space using a pre-trained language models, and the distance between these queries and the document is computed to select the top K documents. Once the top K documents that consist of products and other units of recommendations are generated, these are sent into a separate recommendation system whose goal is to re-rank them and present it in such a way that the user interaction with these recommendations has a higher probability. This is often called the slate optimization. Slate recommendation or optimization, where the recommender system presents the user with a collection of documents or collection of recommendations at once. The logs of this recommendation system is used to refine future recommendations by the use of reward signals like clicks or purchases. We also use multi-AMP bandit algorithms to optimize the slates of recommendations, as bandit algorithms have provable, optimal, and strong theoretical guarantees. The next interesting piece, let's dive into contextual QA. Question answering is a key aspect of any shopping experience. Any smart agent that helps customers to help purchase products has to have the ability to answer questions. But there's a new aspect to this called the conversational question answering, which allows system to advance from just answering standalone questions to answering a sequence of related questions. Such sequences contain questions that usually revolve around the same topic or subtopics, which is how usually human conversations are. The most pronounced characteristics of such sequences are anaphoric expressions and ellipses. Now let's take an example that's on the screen. A customer starts with a simple question like, Alexa, can you FaceTime with Apple Watch? Alexa gives an answer with saying, yes, FaceTime audio is possible. Now the next question customer asks is, can you make a phone call? Now this is called an ellipse because there is no reference to the previous conversation, but customer is still talking about the same topic. Now Alexa understands this and rewrites this to saying that, can you make a phone call with Apple Watch? Then if you look at the next question, how much does it weigh? This is called an anaphoric question because there is an pronoun it that needs to be resolved before answering this question. Alexa now rewrites this question to be, how much does Apple Watch weigh? And answers Apple Watch weight is X grams. Now let's look at the secret sauce behind how Alexa answers these contextual QA questions. At high level, the architecture is broken down into two key pieces. One is contextual question rewriting, and then the question answering systems. The task of in-context question rewriting or query rewriting is to convert context-dependent question into a self-contained question that doesn't need any additional context. The task of rewriting is to formulate every follow-up question in a conversation such that the question is unambiguously interpreted without accessing the conversation history. The input into these query rewriting models is the question along with the previous conversations. Using a running example, the input would be, for example, can you FaceTime with iWatch and can you make a phone call? Now the second piece of this architecture is once a query is rewritten is to actually do a question answer retrieval. This again is broken down into multiple phases where in the first phase, the top K documents are retrieved using traditional BM25 style algorithms to quickly swift through the indexed collection of documents. In the second phase, a more computationally complex models are used to re-rank a limited set of documents. Then finally, the challenge is to find a contiguous span within the given passage, which is called the answer extraction models. Once the answer is extracted, this is sent to the NLG or the natural language module, which rewrites the continuous span into an answer that is read out to the customer, which is then sent to the TTS module or the text to speech module, which is then given to the customer. Moving on to the bite-sized insights. Information on the products is abundant. There are customer reviews, there are blogs, there are forums, there are customer Q&A pages, expert reviews, and the list goes on and on. These diverse opinions helps customers assess whether the product fits their needs or not. They also provide key highlights for the products and shortcomings, if any. These reviews also help customers compare different products. Customers use all sorts of this information to get an understanding on product categories that they're not familiar with and to get a lay of the land. However, this has turned into a really time-consuming research exercise because of the abundance of the information that is available. Alexa solves this core problem by using multi-document summarization and summarizes this information on customers' behalf. Now let's look at how it's done. Multi-document summarization is a task of combining the salient information from multiple documents into synthesized snippets. This summarization can be in two forms, extractive or abstractive. Extractive summarization means that usually the models extract salient snippets from the source documents to create informative summaries. They usually contain two major components, sentence ranking and sentence selection, either from a single document or a multi-document. Abstractive summarization, on the other end, aims to present the main information from the input document by automatically generating the summaries that are both succinct and coherent by generating new words that are different from the source document yet convey the same message. To do multi-document summarization within Alexa, we take a two-pronged approach. We take the documents, use pre-trained language models, and represent them as embeddings and pass them into inputs into a neural encoder-decoder architecture. We also leverage parallelly graph representations of the document to efficiently process multiple input documents and distill summaries out of them. Post the generation of the summaries, we also pass them through factuality classifiers in order to ensure that there is factual consistency between the source and the generated summaries. Once these bite-sized insights are generated, we surface them to the customer based on the contextual query that they are looking for. This is how the bite-sized summaries are generated. Before moving on to the different section, I would like to introduce my partner again, Devesh, to talk about Alexa Conversation Dialogue Manager, which is really at the heart of this experience on how conversations are really natural. Thanks, Devesh.
Thanks, Sandeep. Really appreciate it. So back in 2019, when we had Remars in person, we introduced Alexa Conversations, which was a platform where developers could really build experiences which are truly natural for the end customers. The base fundamentals of it comes from three principles. One is the massive computation power we have harnessed over the last few years, a wide variety of signals which we have been getting to train those models, and the improvements in AI algorithms themselves to enable all experiences for AI, including Alexa and other voice assistants. As we've used Alexa in particular, hundreds of millions of customers have been using it for one-shot utterances for smart home, to music, to alarms and reminders. So when you ask Alexa to turn on the lights, it works seamlessly because you have a very specific goal in mind. But there are times where our customers demand more from us. They want Alexa to help them navigate when they don't really have an end goal in mind, but they broadly know what they want. So let's look at the example on the right. Alexa, what should I read? The customer doesn't really know what they want, but they are looking for recommendations, and that's the kind of an experience which requires a back and forth. You make some suggestions, and the conversation builds on top of it. In this case, Alexa recommends, based on your past reading histories, what it might find something that would resonate with you, and the customer decides, hey, if I can get a summary, I can make that decision. The customer hears the summary and can actually purchase it, and that's really an end-to-end customer experience going back and forth. Now, for voice AI, the scripted experiences are relatively easy to address. There is, of course, a challenge of speech recognition and other aspects. But the conversation, if it follows a particular path and you know that this is the order in which things would happen, it's relatively easy to mimic. But the natural conversations do not go that way. So like, for example, in the last scenario, the customer might have as well said, instead of the summary, show me from a particular genre, by a particular writer or author, and that would have made it really hard to follow these natural conversations. The additional challenge that comes along is, as we've built more devices, some have screens, smaller screens versus larger screens, some do not have screens, some are mobile versus some are stationary, and we want to give an experience which is consistent across those. And that is where we think Alexa Conversations comes to the forefront. For all these experiences which we've been talking about, we can build all of them by writing extremely high lines of codes to cover for all scenarios. But the moment you think about a conversation which goes beyond 10 turns, the combinations explode, and it's not possible to write for all those scenarios. And that is where Alexa Conversations solves that problems on two fronts. One, fewer lines of code, and second, fewer annotated data samples to train your models. We'll learn about how it does it in the next couple of slides to give an idea of how it goes behind the scenes. There are two aspects to it. One is synthetic data generation, and by that we mean is the model actually predicts all the possible scenarios we could potentially be going through. So the developer provides us some APIs, some slots, some response templates, and some sample dialogues. Now the actual customer journey can go through a wide variety of them, and the simulator helps us produce tens of thousands of such combinations, and the developer does not need to write all those combinations. That is a true differentiator, because you're no longer thinking about all the possible scenarios the customer journey could go, but are simply stating the APIs, the slots, and some possible response templates. The other part of it is the modeling architecture. It's a conversations first architecture. What it means is, every time you interact with Alexa within a session, we update the context to do the next predictions. There are three key models which work for us. One is entity recognition, action prediction, and argument filling. Entity recognition helps us identify the entity you're talking about. So in the previous example, that's how we would reference 8 from when we are talking about Apple Watch, how much does it weigh, as Sandeep was mentioning. The second is, once you have the entity, you decide an action, whether it could be calling an API, it could be an NLG, or it could be a request for an argument filling because an API needs more requirements for the customer request to be fulfilled. Now, if all of these happens, we take an action on behalf of the conversation, on behalf of the dialogue manager, and feed the dialogue history. The customer responds back, and the same process repeats again. And this is a true differentiator because the story can go again and again, and every time the customer inputs something, the dialogue history is enriched, making the customer move further along in their journey. Now, as we build upon these multi-turn conversations, one of the things we realized is saying the wake word Alexa every time is not natural. When I and Sandeep are talking, we're not talking, hey Sandeep, all the time. It just
Alexa.
Sorry about that. We have to go back. We're not talking, hey Sandeep, all the time. We just naturally talk, and it's assumed the shared context continues. And that's when we started building more and more experiences with Alexa conversations. We realized the need for, this seems to be going back again. Sorry about that. That's when we realized that the need for the conversation to be natural. It does not need to have the wake word every single time. For that, we build the conversation mode so that I'm sorry about that. Let's watch a demo of the same to
Alexa,
see how
join
the
our
experience
conversation.
works.
Okay, let's talk.
We'd like recommendations for a good action movie.
Here are some movies you might like.
But we just watched one last night. How about show us drama movies?
Here you go.
What is the first movie about?
Sylvie's Love is about a young woman who meets an aspiring
Is it a good movie?
Sylvie's Love has a 6.8 rating.
I've seen it. It's not my favorite, but Lance Reddick was great in it. And he was great in John Wick. Can you show me other movies with Lance Reddick?
Here are some movies you might like.
What do you think about One Night in Miami?
Yeah, that sounds good. I heard good things about the movie. Okay, play number 3.
So, as you can see, a truly natural conversation should not require a wake word interaction. It should allow people to speak normally because that's what humans do. We speak over each other, we interrupt each other, and at times we also want the conversation to change courses naturally. With conversation mode, all the examples you're seeing currently were around experiences with shopping, but we wanted to show that the core technology behind can serve in a wide variety of use cases. For the example you saw before, it was to select a movie. Similarly, we can use any experience which could be tailored to have a wake word free experience. Now, we talked about conversation mode and Alexa conversations as two separate experiences, but we wanted to highlight that it's not only for Amazon experiences. All external developers can use Alexa conversations to build delightful experiences, and almost hundreds of developers have already built it. We've also built some flagship experiences with our partners like Ring, where we build Alexa greetings on Ring doorbells. We also build What Should I Watch and the What Should I Read Next experience you saw to help you decide what books to read or what movies to watch. With that, I would like to conclude and thank you everyone for joining us.